Okay, welcome to Math for Electronics ET 111B. I'm Art Eggers, and I will be your instructor for the course. In this first section here, Lecture 1, we're going to look at actually all 4 chapters for the section known as Review of Arithmetic Fundamentals. And we're going to go back and take a look at everything from decimal systems, using the powers of 10 within the decimal system, units and prefixes, and fractions, decimals, and percents. So we're going to move quickly through this because this should be all material that you learned back in probably up to about the 8th grade and into the 9th grade if you took high school algebra. So all of this stuff, although you may be rusty, it should be stuff that you have in fact seen before. So in Chapter 1, we're going to concentrate on the decimal number system, learning or relearning how to use decimals and decimal fractions, whole numbers, the fractional portion of the decimal, rounding, significant digits, and using the operators addition, multiplication, subtraction, and division. So in the objectives, we're going to go back and look at developing or redeveloping our understanding of the decimal system, how to read those values, do some conversions using the operators, signed numbers, and rounding. So the decimal system means exactly, deci means 10, so 10 digits. In this case, 0 through 9, and then we start over again starting at 10. Each digit is a weighted position within the base 10 or the place value system of base 10. This chart, to start with, you need to ingrain this into your memory. You need to have this at your fingertips. If you don't have a copy of it handy, make a copy of it and keep it handy so that you can continually refresh yourself until this becomes second nature. Because this allows us to look at the weighted system. In this case, 24 is telling us that if we look at this section here, the chart tells us tens. We see that 2 is in the tens position, so that becomes 2 tens or 20. If we look at this number, 5,264, the 2 now is in the hundreds position, 5,264. In this one, the 7 is in the tens position. It means that there are 7 tens or 70 represented by that position. This table becomes handy, again, if you're going to keep anything else handy as a reference to remind yourself what we're looking at in terms of operations or operators in the arithmetic systems. When looking at fractions, we have to determine what the numerator is, what the denominator is. The little line between it we call the vinculum. This becomes important when we look at decimal fractions because in this case we're looking at the whole number 10 in the denominator. Okay, so the denominator 10, in this case 7 tenths, in this case 1 tenth, 2 tenths, 3 hundredths, 1 thousandth, 12 ten thousandths. Okay, so we're using the 10 values. Later we're going to convert those to exponents and make it a little easier to read, and then later we're going to make them into the metric notation. So we need to be able to read this very fluidly. 4 thousandths, 4 over 1,000. 5 tenths, 27 hundredths, 27 thousandths. Okay, so in this case, we get used to reading with factors of 10 in the denominator and whole numbers in the numerator. Okay, and we will start using them as decimal numbers. In this case, 47 thousandths becomes the value represented as 0.047. The 7 telling us that we are looking at thousandths. In this case, 423 thousandths could just as easily be represented as 432 divided by what? 10 to the third or 1,000. Keep track of the rules in your textbook. Rule number 1 in dealing with conversion of decimal fractions to decimal numbers determines by the value of the denominator. So we go back to that representation, 17 divided by 100, 17 hundredths then, or the decimal relationship, 0.17 is 17 hundredths. Rule 2 then says convert decimals to decimal fractions, determine the position of the rightmost digit. That becomes the value of the denominator. So when we look at this, the rightmost digit in this case is a 9. It's in the thousandths position, so this becomes 39 thousandths. Whether you handle it as a decimal fraction or a decimal number. Your text has lots of examples. I suggest you go through the examples as you are reading through your text and make sure you understand thoroughly what this example is trying to teach you. You can learn everything you need to know by working through the examples and then later working through the problems. Key points show up. In this case, the first one says mixed numbers are numbers that are made up of a whole number part and a fraction. We use the and to determine where the decimal point is. So 13 and 36 hundredths, then we use the whole number part fractional value fraction itself, and we can see it becomes 13 and 36 hundredths. Okay, again, the chart is something that we need to be used to and very familiar with. Whole numbers and fractions then, work through these examples, make sure you see how we convert from the fractional portion to a fractional representation. In rounding, the rules are generally anything a number greater than 5, we round up. Anything less than 4 or less, we round down. So in these examples, if we want to round to the nearest tenth, we have a 5, so that's telling us round up. The nearest hundredth, we have a 3, that means round down. The nearest 1,000th, we have a 7, round up. Okay, these apply both for fractions and whole numbers. Okay, an example here, to the nearest 100th, then this becomes 1274 to the nearest 100th. To the nearest tenth, 3 is next to the tenth, so that becomes a round down. To the nearest 1, 7 is next to the 1, so we round up to the next value. And the same thing with the tens digit. In rounding whole numbers, remember that in rounding whole numbers, the 0 is a placeholder, but it cannot be dropped. If a 0 exists in the rightmost position, as a result of rounding, the 0 is dropped because it's not accurate. The last section here that we'll talk about is significant digits. Key point, significant digits or significant figures, you can use them interchangeably, are the digits in a number not counting leading zeros that are known to be accurate. So the term significant digits is used in conjunction with the process of rounding with significant notation. So here we can see the example 0.04. 4 is the one significant digit in this representation. The 0 to the left of the decimal point tells us there's no whole number part. The second 0 is important because it states there are no tenths. So neither of the zeros are considered significant digits. In looking, though, at trailing zeros, the rightmost zeros are considered significant digits when to the right of the decimal point, because their presence indicates a known accuracy. So you have to be mindful and aware of these digits when you're dealing with trailing zeros. So in this case, 52 with the 2 trailing zeros makes all 4 of those significant digits. I know it can get confusing, but it's something you just have to remind yourself of. Go back to the rules if you get confused. 5,000 here, though, has 4 significant digits, but it may be ambiguous if it was rounded up to the nearest thousands. This could have been 4,735, but it was rounded up to 5,000 and has 4 significant digits. So if we look at moving the decimal point as we do in this example, you can see that 4 significant digits remain the figures that are important in maintaining the accuracy of this number. Okay, getting used to what is the most significant and the least significant digit, MSDs and LSDs, usually it's pretty simple. The first one to the left is the most, the smallest one to the right is the least significant digit. So we can take this number 79,630 and identify each of its weighted positions and determine from this what is the most and what is the least significant. This is stuff that you just have to be aware of, because when you are doing calculations, these are things that become important. Okay, so for maintaining accuracy. So the next section, addition and subtraction of signed numbers, we'll stop here.